Hello maths fans, Dr. Tom Crawford here at the University of Oxford, and today I'm taking an Australian high school maths exam. I'll be taking Mathematics Standard 1, which comes from the higher school certificate, which I believe is the highest level of qualification you can obtain as a high school student in Australia. The paper comes from 2023, so it's pretty recent, and this particular version is for the New South Wales region of the country. The total mark is 80. There are two sections. The first one is multiple choice. The second one is the open form questions. I am allowed to use a calculator, but of course, as we know by now, I don't have one, so we'll see how that goes. And I have a maximum time of 2 hours. Let's do this. Section 1, multiple choice. 10 marks, allow 15 minutes for this section. Hopefully I'll be doing it faster than 15 minutes, we'll see. Okay, use the answer sheet. I'm going to write it here. Question 1. What is 4.268 when rounded to 3 decimal places? That would be 4.268. 4.268, because we're going to go down, because then it's 19. Great. Question 2. An amount of $2,500 is invested at a simple interest rate of 3% per year. How much interest is earned in the first 2 years? So after 1 year, you have 2,500 times 1.03. So 1%, let's think about this. 1% equals, divided by $125. So 3% is $75. So we get $75 in year 1. And then we have 2,575 after 1 year, and then we have to multiply again by 1.03. So what's another 1% of that? That's now 25.75. So then times 3 gives me 3%. So it's 75 plus another, 75 plus an additional 2.25. So I think the total interest is what? 75 in year 1 and then 77.25 year 2. So, it's, I've done compound interest and it's simple interest. Great, read the question, Tom. It's B, it's clearly $150. God damn it. Already not reading questions. Okay, question 3. Note to self. Read questions. Question 3. Towns are 5 centimeters apart. Okay, 5 centimeters, and the scale is 1 to 100,000. So that means we are 500,000 centimeters. So 100, so that's 5,000 meters, because 100 centimeters is a meter, which is 5 km. So A, 5 km for that one. All right. Number 4. I'm probably going too fast, but time is of the essence. There's water in a pool, which is in the shape of a triangular prism. Pool is being emptied of water. Which graph best illustrates? So if I assume it's being emptied from the top or the bottom even, it's going to go, the depth will go down slowly at first, and then it will rapidly speed up. But it will be pretty continuous. So the depth is high and then becomes lower, and it's going to be nice and continuous, so it has to be D. D, I think, for that one. Question 5. Following is part of a credit card statement with some figures missing. Oh God, here we go. Right, opening balance, $506. This is very real world maths, I like it, very helpful. Plus new charges minus payments. Okay. So, opening balance plus new charges. So the new charges were 85.97 plus 4.64 because of the interest. That's a new charge. Yep. So that's got to be the next one up. So that's 90.61. Yep. For new charges. Closing balance is then, so that's like 596 minus 118. 596 minus the 118 it's got to be 477. Yes, 477.71. Because it's basically minus 119. Yes. 47. I think it's got to be D. Just from like a process of elimination. Again, I should use a calculator, but I don't have one. Okay, 6. A delivery truck was valued at $65,000. The truck depreciates at a rate of 22 cents per kilometer. I need a calculator. God damn it. 132,600 km and 22 cents per kilometer. So that means it's going to be $2.20 for 10 km. It's then going to be $22 for 100. It's going to be $220 if it's done 1,000, but it's done 132,000. Oy. So 2,200 if it's done 10,000, 22,000 if it's done 100,000. So then if I want 132,600, that's 100,000 plus 3 lots of 10,000 plus 2 lots of 1,000 plus 6 lots of 100. So split that up into the costs. So 100,000 is 22,000 plus 3 lots of the 10, which is 2,200, plus 2 lots of the 1,000, which is 220, plus 6 lots of the 100, 6 lots of 22, equals 22,000 plus 6,600 plus 440 plus 132. So the total is 29, 172, something like 29,172. The price they want is its value now, so it's lost that. So it started at 65,000. So now I subtract 29,172. So I'm going to get something like 35,828. So it's going to be A. Okay, so that one I think is A. Right, number 7. An item was purchased for $880, including 10% GST. I'm going to assume that's like Australian VAT or something. What is the amount of GST included in the price? So what do I know? I know that X plus 10%, I think, is going to be $880. Yes, 0.00. So if 880 is X plus 10%, then it's 110%, so it has to be $80. Yes. C, $80. Let's go with it. Okay, number 8. Not overthinking these. Speedily as possible. 4 cards marked with the numbers 1, 2, 3, 4 are faced down on a table. 1 is turned over. It's probability the next card turned over is marked with an odd. So 2's come up, so there are 3 left. 2 out of 3 are odd, so D. Cool. Question 9. A bag contains 150 jelly beans. Some of them are red and the rest are... It's like beads and balls, but now we're doing jelly beans. Much tastier choice of item. The ratio is 2 to 3. Sophie eats 10 of each colour. Okay. Interesting. So 2 to 3, so that means there will be, how many then? 30, so 60 to 90. So 60 red, so R equals 60 to 90 for blue. She eats 10 of them, so now it's 50 to 80, so that's 5 to 8, so that's C. Great. And finally, question 10, finally for multiple choice. Tap is dripping at a rate of 4 milliliters per minute. Which expression shows how many liters this would amount to in a year? Okay. 4 milliliters per minute, so that's... Oh, okay. So it's 4 per minute, so you want to do 60 minutes, 24 hours, 365 days. Yes, that would give you it in milliliters per year, but then you have to divide by 1,000. Yes, so I think that's B. Awesome, multiple choice complete. Let's move on to section 2. Right, section 2, what have you got for me? Hopefully I won't have to rush through them as quickly. We'll see. Okay, so in theory, I have 1 hour and 45 minutes for this section. There are 21 questions, ouch, for 70 marks. Okay, right, well, no use wasting any more time. Question 11. What are we doing? Okay, the annual income of the employees is shown in the grouped frequency distribution table. Sure. What are the values of A and B? What is this? Company employs 50 people. Yes. So that's the annual income, and then f of x is f multiplied by, yes. So A is 15 times 65. Need a calculator. A equals 15 times 65,000. So that's 650,000 plus half of that again, which is 325,000. So that should be 975,000. And then B is the total of that column. So B is the total of the FX column. I really should have a calculator, but anyway, so it's 540, so this is in hundreds of thousands, it's 540, 715, the one I just worked out, 975, 525, and 255. Right, so adding those up, I get a 0, and I'm going to carry a 2, 4, 5, 12, 13, 14, 19, a 1, and carry a 2 again, 5, 7, 12, 21, 28, 30. So I think it's 3,010,000, I think, for B. Okay. Find the mean for this distribution. Sure, so that was part A. Let's keep this noted. Part B, it wants the mean. So the mean is, I've got the middle value multiplied by the number. That's what they're calling fx here. So it's b divided by 50 is the mean. So the mean x bar is 3,010,000 divided by 50. So that's like 60,000, and then there's that other 10. So it's like 60,000 and then 10,000 divided by 50. Is it 60,200? Would give me that additional 10,000, would it? Yes, I think it's 60,200. Cool. All right, question 12. I hope they're all like this. This is nice. A floor plan. Interesting. Doesn't feel like a maths exam. Apparently I'm taking architecture now, or design tech, or something of that nature. But I do like the practicality. I shouldn't joke about this. This is nice to get real world maths questions. I like it. Don't know if this is just how you do things in Australia, but I'm a fan. Okay, floor plan is showing dimensions are in millimeters. What are the dimensions in meters of the living room? So it's 5,200 millimeters lengthwise, and then its height is 106, it's 3,600 plus 160 plus 2180. So that's 5.2 meters by whatever this is in millimeters, and then I'll convert to meters. So that's going to be 2180. That makes 2340, 2340, so 5940, so 5.94 meters, I think, is my living room. Right, kitchen floor is to be tiled. Okay, each tile is 40 by 40 centimeters. How many tiles are needed? Literally, so practical. I love it. So what is the kitchen? It's 3,200 for the top bit, the grey area, not the bit with the counter. 3,200 by 3,600. Yes. So it's 3,200 by 3,600, and that will be in millimeters. So that's 320 centimeters by 360 centimeters. So to tile that, you need 8. That's 8 times 40. And then you're multiplying that by 9 lots of 40. So if each one is 40 by 40, then you only get 72 because you'll need 8 one way, 9 the other way, 72. Is that what it was asking me? How many tiles? Yes, how many tiles? 72 tiles is what I think is the answer. Oh, there's a part C. Keep it going. Tiles are supplied in boxes of 10. Only full boxes can be purchased. How many boxes need? We need 8 boxes because we have to, annoyingly, we're going to need those extra 2 above 70. I have to buy an 8th box. All right, let's keep it rolling. Question 13. Another graph showing the frequency of scores out of 10 awarded to a museum by visitors. What is the mode? Mode means most common occurrence, so 9. A mode is equal to 9. Great. Describe 2 features of this graph. Okay. It's a bar chart. I have no idea what I'm meant to write. Describe 2 features of this graph. Maybe the idea that 1 is an outlier, possibly. I'm going to have to write down more than 2 because I have no clue what kind of features it wants. But I think the score of 1 is an outlier because it's far away from all the others. How many people were asked? I could work that out. That's 1, 2, 4, 7, 13, 21, 24. So there are a total of 24 people were asked. So the total is 24 people that were asked. I could probably work out a mean. What else could I do? Range, maybe like a range. So the range is 9 because it's the max score of 10 minus the minimum score of 1. Hopefully that's enough. Who knows? I'm moving on. Question 14. Another graph, but distance time, shows the first 2 stages of a car journey. Okay, sounding interesting. From home to a holiday house. Okay, there are different ways of living over in Australia if we are driving our car to our holiday house. Okay, not really sure what to make of this. Right, so we're going to go stage A for 1.5 hours. So we're going 1.5 hours. Ah, right, and there we go. So it's 1.5 hours to travel 150 kilometers, and it wants to know my speed. So it was 150 km in 90 minutes, or in 1.5 hours, which is also 1.5 hours. And it wants it in kilometers per hour. Right, so we're traveling 100 kilometers per hour. Okay, cool. 100 kmph. Brilliant. For how long did the car stop during stage B? From 0.5 to 2, so 0.5 hours. B is 0.5 hours. It stops, which is 30 minutes. Grand. Part C. After stage B, the car continues to travel towards the holiday house at a constant speed of 50 kilometers for 2 hours. Graph it on the... I don't have the grid. Okay, I'm going to draw it here, and you're all going to... I'm going to explain it all so you can all believe me when hopefully I give myself the marks later. Because I'm not drawing the whole thing out. Right. So what have we got? We are time, hours. It's going to be a sketch of the route. Distance, km, from their home. So we travel until we get to 1.5, and that was at a constant speed, and we reached a distance of 150. We then stop for half an hour, and then we're going to continue now at a constant speed of 50 kilometers an hour for 2 hours. So we're going to go until we get to 4, and we're going to travel another 100 until we get to 250. So that's up here. So the point is that this is flatter, right? So this is then traveling from 2 to 4. We're going 50 kilometers an hour, whereas before we were going 100 kilometers an hour. We were going a lot faster earlier. So this has half the gradient. Gradient is less steep than the first part, and in fact it's a half. In fact, it's a half of stage A. Okay, so hopefully that convinces you that I know what I'm doing with these graphs. Maybe. Anyway, question 50. So not only do I need to get myself a calculator, I need to write on exam papers, is what I'm learning. Nonetheless, the table shows some of the flight distances, ooh, this is fun, between various Australian cities. Because of course, Australia is so big, you basically have to fly between the east and the west, that's for sure. Right, okay, around his nose 10 kilometers. Use information in the table to complete the network diagram where the edges are labeled with distances. I'm glad it's put the cities in their location, because I'm not sure I would have known exactly where all of them were. Okay, so what have we got? We have, we've got a D up here. It's Darwin to Perth. And then we've got an A sort of here. Not my geography, this is copying theirs. H down here, is that Hobart? Yes. And then we've got a Brisbane and a Sydney sort of over here. Right, fine. So they're putting B here and S here. I think that's where they are, roughly. I don't know how to scale this this chart is, but anyway. So it wants me to connect when you can fly between them, right? Because you can't fly between all of them. Gotcha. So Adelaide to Brisbane isn't possible. Adelaide to Darwin isn't. Adelaide to Hobart is 1170. Okay, so that's 1170. And then we've got Adelaide to Perth is 2120. Okay, so that's, I'm just going down the first column. Brisbane to Darwin is 2850. So that's that one. That's 2850. Great. And then Brisbane to Sydney is 750. 750. Fabulous. Darwin to Brisbane, 2850. Yep. Darwin to Perth, 2650. Got it. Darwin to Sydney, 3150. So that one's going there. And that's 3150. Cool, that was a new one. Hobart to Adelaide, 1170. Got it. Hobart to Sydney, 1040. Awesome. Perth to Adelaide, 2120. Got it. Perth to Darwin, 2650. Got it. Perth to Sydney, 3270. It's that one. It's a big boy. Across the width of the country. And then Sydney to Brisbane, 750. Yes. Sydney to Darwin, 3150. Yes. Sydney to Hobart, 1040. Yes. Sydney to Perth, 3270. There we go. Okay, how many marks? 2 marks for all that. All right, well, it's drawn. Massa wants to travel from Hobart to Darwin. She wants to change planes only once. Okay, so she wants to go Hobart to Darwin. So you have to go via Sydney. So your options are you can either go Hobart to Sydney or Hobart to Adelaide, but if she goes to Adelaide, she then has to go to Perth and change a second time, so that wouldn't work. So she has to go H to S and then S to D because she only wants to change planes once, and that is the only possible route from Hobart to Darwin with a single change. So that's 1040 plus 3150. So the total there is going to be 4190 km. Sweet. Okay, question 16. Oh, nice diagram. At the top of a vertical cliff, 120 meters high, a boat is observed. The angle of depression of the boat from the top of the cliff is 18 degrees, as shown in the diagram. Sure, so you've got a cliff, which is going to be 120. Important. We then have the down to the boat, which is here. Okay, this is the boat. Great, and then we know that that is 18 degrees, so we know that that is 72 degrees because the total is 90. Fabulous, and we also know that this is a right angle triangle. Awesome. Find the distance of the boat from the base of this. This is how we should teach trigonometry. Actual uses of it, it's amazing. Okay, so we're working out from our lighthouse or cliff how far away the boat is. Perfect application of trigonometry. I love it. So I'm actually really enjoying this whole application. As you can see, I'm getting very excited and throwing my pencil around. I'm getting very excited by this whole like application-based exam. But anyway, I'm stalling. Distance from the boat base to the cliff. Sure. So what do we know? We know that one and we know the angle. So I want to know x. So I want to know opposite and adjacent. So it's tan. So I know that tan of 70, oh no, don't have a calculator. Tan of 72 degrees is equal to opposite over 120. So my answer is x is 120 times tan of 72 degrees. And I'm going to assume I'm going to need to know that. So I'm going to have to Google tan of 72 degrees. Let's see if this works. I think it might. Tan of 72, no, it's giving me in radians. It's not that. Degrees, please. And let's try again. 3.08. So it gives me, and then times 120. 120 is 300. That sounds about right. And so it's 369.3 meters. And what did it want the answers in? Nearest meter. So it's therefore 369 meters. Awesome. Right, is that it? That would appear to be it. Let's move on to number 17. We have an equation. P is equal to 10n, it's like, I thought it was newtons at first, minus 7.5 m divided by 9. Okay. Find the value of P when n is 6 and m is 2. Okay, sure. So if n is 6, m is 2, they tell me that P is 60 minus 15 over 9, which is 45 over 9, so P is 5. Sweet. Okay. All right. Like that one. Number 18. A network of running tracks connects these points. Oh, complicated old network. Number on each edge represents the time a typical runner should take. Okay. What path could a typical runner take to run from point A to point D in the shortest time? Right. Oh, man. So I can see a possible route, but I wonder if there's a shorter one. So we need to go from A to D. So I've got 3 choices where to leave A. So 3 would be the shortest. So if I went along the 3, because it's the shortest, you want to minimize, I'm then at B. Oh, and then I can do 1, the shortest from B. Ah, gotcha. So if I go A to B, and then take the shortest from B to F, so that's 3 and then 1. And now from F, the shortest would be a 4, but then I've got a 15 and that's not going to help, or a 9. But I could just do a 5 to get to G and another 5. So I think I want to go B, F, G, D. So there's a little bit of trial and error in there, but I was generally trying to pick the shortest route at the point I'm at, as long as it's not taking me away from the end goal. So I think that's going to be 14 minutes, is my guess. Right. A spanning tree of the network above is shown. Excellent. Is it a minimum, minimum spanning tree? Now I have to think about this. So it's a spanning tree. Now, is it a minimum spanning tree? So that means, is there a shorter route between these points? So if rusty on this, I think minimum spanning tree, I think, is that you're showing the shortest distance between those points, I want to say. So if you look at A, that's A via B is the shortest route to get to F, yes. H to get to E would be shortest through F, yes. So F is really important, gotcha. B to C, that is the shortest. F to G is the shortest, and G to D is the shortest. I think it is, yes. So I think I think B is a minimum, it is a minimum spanning tree, since it has the shortest roots between, shows the shortest roots between pairs of points. I think. Something of that nature. Anyway. All right, let's move on. More graphs. Scatter plot, first one we've had of those, I think. There's a number of ice creams sold at a shop over a 10-day period, and the temperature recorded at 2 p.m. on each of these days. Excellent. So there's a nice positive correlation. Great. So as it's warmer, you sell more ice cream. Yep, nice. There's also more deaths by drowning as it's warmer as well. Interesting fun fact for you. So you can link, you think about this. More ice cream sold means more deaths by drowning. Classic correlation causation example. Of course, they're both linked by temperature. But, you know, without knowing that, you could think they were linked. Anyway, now what we're doing here, we're doing ice creams versus temperature. Sam used a particular temperature with this equation and predicted that 23 ice creams would be sold. Okay, what was the temperature used by Sam to the nearest degree? Okay, so we're drawing a line of best fit. Fantastic. Sure. So he's going through 9, and it's approximately 1. Okay. So I think as an approximate model, what would the approximate model be? Because obviously I can't plot with that level of precision. But the approximate model is suggesting y looks like x minus 9, I think. Okay, and so he's predicting 23 ice creams, and y is the number of ice creams. So if he thinks 23 is equal to x minus 9, then 32 is approximately x. Does that make sense? I think so. Oh. To the nearest degree, I'm going to go with 32. I'm not sure what else I meant to do, unless I meant to plot that exactly, but then it wouldn't know the data on my calculator. I'm going to just assume that I have an approximate model. Oh, wait. Oh, no. No. What am I doing? I can use the exact model, right? Because I can just say 23 ice creams. I'm forgetting I, in theory, have a calculator. 23 is 0.936 times the unknown x minus 8.929. So I'm getting that 30, not quite 32, 31.929 is 0.936x. So it's actually going to go up a degree then, isn't it? So x is equal to 31.929 over 0.936. I think that's going to be approximately 33 degrees. He says hoping. Can I check that on a I should check this on a calculator, shouldn't I? All right, 31.929 divided by 0.936. Oh, is apparently 34. Glad I checked. 34 degrees when I actually use my calculator. Okay. I will never learn. I will never learn. Part B. Apparently I just dislike calculators. In using the equation to make the prediction, Sam was Sam interpolating or extrapolating? He was extrapolating because he wanted to predict outside of his data. So he was extrapolating since x equals 34 degrees is beyond the range for which he has data. Okay. Awesome. Right, is that it? Question 20. What are we doing now? We have a data set. Consider the following data set. Is 58 an outlier? All right, well, let's write it out. 22, 27, 29, 32, 36, 37, 39, 45, 47 and 58. Right. So it's bigger than most of the others, but an outlier means it's like really far away. And I want to say I'd calculate the standard deviation. So I don't know if my calculator would do this, unless, wait, have I written that out right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10, 3, 4, 5, 6, 7, 8, 9, 10 of the values. So the median is in the middle. Yes, so like 36 and a half. Okay, so if I say the median is 36.5, it's between those two values, right? 32, 36, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. Okay. So I'm thinking interquartile range, and something in my brain is telling me 1.5 times the IQR away from the median means an outlier, I think. I don't know where I would have pulled that fact from if it wasn't something I learned at school. Have I used it in the last 15 years? Absolutely not. However, I want to say it's 1.5 times the interquartile range. So that gives me then this one is the lower quartile, and this is the upper quartile. So there's a lovely interquartile range. So the IQR then is 45 minus 29, which is 16. So then the median is 36 and a half. So 1.5 times the IQR is going to be 24. And then if we add 24 to like any of those values, the middle value, I think it's the median plus the IQR. So point is, what is the point? 30, so the median plus 24, which is 1.5 times the IQR, is like 60.5. And the point is that's greater than 58. So therefore 58 is within 1.5 lots of the interquartile range from the median, which implies it is not an outlier. It has to be more than that away to be an outlier. So I think no, and that's my working. All right, 21. Keep them going. Okay, I think that means like 10 or so left, something like that. Okay, an amount of $12,000. Oh God, now it's compound. Of course, now it's compound interest. Okay, $12,000 into an account that pays 1% interest per quarter. So it's times 1.01, but it's that to the 4 per year because it's going to compound. Yes, and it's doing it for 5 years. So in 5 years there are 20 quarters. So I need to do 12,000 times 1.01 to the power of 20. That's what, and I can't do that in my head. Calculator again. So I can do this. 1.01 to the power of 20 is some number. Yes, and then you multiply that number by 12,000, the actual money I had. And I get 14,642. And if you want to do it in cents, pounds, dollars, Australian dollars, 28 cents. Okay, and I think that is what they want me to do. Sweet. Let's move on. So now it's telling me questions 11 to 21 are worth 36 marks in total. So that's what I've done. Okay, so now I'm moving on to the next bit. I don't know if that means there's like a change, but I'm like halfway through section 2, approximately. Meh. All right, so let's go to question 22. Okay, the hours worked last week by Rose are shown. Her normal rate of pay per hour is 24.05. How much did she earn? So practical, I love it. Okay, so we've got 8:30 a.m. until 12:30 p.m. That's 4 hours. So she does 4 hours, 4 hours on Monday to Friday, so that's times 5. So that's 20 hours at the normal rate for Monday to Friday. Then she's doing, on a Saturday, she then does 2.5 hours, so that's 2.5 hours at time and a half, 1.5 times rate. And then Sunday she does 3 hours at double. So the total then is 20 hours at $24.05. That's from Monday to Friday. Then she gets 1.5 times it. So plus 2.5 hours times the 1.5 multiplier on the rate times 24.05. And then for Sunday, double rate, so 2 times, and she does 3 hours. So 3 hours times 2 for double rate times 24.05. So it's some amount of 24.05. So it's 24.05, and then we've got 20 of them. 2.5 times 1.5 is 3.75, and then another 6, 9.75. So it's 20 times 29.75. All right, so I think it's 24.05. Calculator again. Really should get a calculator. 29.75 times 24.05 is, I can't read it, 715.49, if I round up. So I think she earned $715.49. And I'm going to assume that's it for question 22. Right. Question 23. The table compares the fuel cost of a petrol car with an electric car. Nice. June travels on average 35,000 kilometers per year. How much will he save on fuel costs by using electric? Okay. Interesting. Let's work it out. So for petrol, what would the cost be? And then electric, what's the cost? See the difference, see how much he saves. So he's, oh God, 8.6 litres per 100 kilometres. So we need to do 8.6 times how many lots is he doing of 100? He's doing 350 lots. So 350. And that's the total of litres. And then you multiply that by $1.87 and then times by 1.87, and that gives you the cost. So, calculator back. And these are better not just calculator questions. 8.6 times 350 times $1.87 gives a total cost of $5,628.70. Seems very reasonable for a yearly petrol cost. Now, electric, same idea, but now for every 100 kilometers, so it's 18 kilowatts. So it's 18 kilowatts times 350 lots of 100 kilometers. So that gives you how many kilowatt hours? And then multiplied by 0.25. Great. So can simplify that because 18 times 0.25 is 4.5. So it's 4.5 times 350. Oh, I can do it in my head. Come on. 4.5 times 350 is 1,400 plus another half is 175. 1,575. Wow. Huge saving. So he saves 5,628.7 minus 1,575. That is what? If this is true, this is wild. So he saves a whole host of money, saving like $4,000, 4,000, 5370, 405370, which is a lot of money by switching to electric. I hope that's true. And also I should probably switch to electric. I don't have a car. If I had a car, I'm getting electric if this is true. Question 24. What is next? All kinds going on here. Got wages, we've got saving money by changing our car. Now we're doing investments again. All right. Bobby invested 5,000. Shows the progress of his investments over the first 4 months. What are the values? Okay. So he's compounding his interest. Yes. So we need to do, so A therefore is equal to, so the value A is 0.6%, so that's not 0.6, that's 0.006 as a percentage, times the amount he has, which is 5090.54. 5090.54. Calculator. I feel like these are all just calculator questions, aren't they? Anyway, just to spite me, 6 times 5090.54. So I think he's earning $30.54. $30.54 is A, and then the balance, you just add it on. So his total balance, therefore, is, so B is equal to the old total, 5,090.54 plus 30.54. So that's 5121.08. Right, 5121.08 for B. Bobby could have earned simple interest on the investment at 0.62%. How much would he have earned over those 4 months? This is so helpful. It's like fuel cost, wages, how to invest your... This is, I love this. Australia, well played, well played. I like this a lot, so practical. And also, you know, some fiddly calculations too, but very practical. I like this a lot. Well played, well played. All right, to do the question, part B, simple interest. So if he starts with 5,000, then he earns $30. No, he doesn't. He earns 0.62. Ooh, okay. So if 0.6 equals $30, and then if he wants 0.62, oh God, that's going to be a little bit more than $30, isn't it? Let's just do it. 5,000 times, I could do it in my head, but anyway, 5,000 times 0.0062 is $31, right. So $31 each month. So after those 4 months, total is that what I need to know, the total? How much interest? Yes. Interest and equals 4 times 31, which is going to be $124. So he'd have earned more interest by doing that. Is that the... Oh, I thought he was going to tell me to evaluate which one was better. Should have done the simple one for the short time period. Longer time period, compound is definitely going to be better. But short time period, simple would have been better for Bobby. Okay, question 25. An artwork. Now we're selling art to go with our holiday home. Or maybe we have come up to hard times and we don't want to sell the holiday home, so we're selling the artwork. An artwork is currently valued at $15,000. Okay. It appreciates at a rate of 5.3%. Right, so it's 15,000. After 1 year, it's 1.053, and then continues to appreciate, so it's that to the 8. Not doing that one in my head. So 15,000 times 1.053 to the power 8. Yes, I think that's right. 1.053 to the power 8. Yes, and that reckons it's 22,673.48. 22,673.48. That is a nice tidy profit over those 8 years. Cool. All right. Question 26. Again, super practical. Electrical providers. Provider A charges 25 cents per kilowatt hour plus a fixed monthly charge. Okay. Complete table showing providers A monthly charges for different levels of electricity usage. Sure. So that's the $250 for that. So it's 400 times 25 cents. So that's $100. So that's going to be $140. Right? Yes. $140 is to complete the table. So A is $140 for that one. Provider B has no fixed monthly charge but charges more. The graph shows how provider B's charge vary with the amount of electricity used. Great. And it's going to ask me to see which one is better. On the grid, graph provider A's charges from the table in part A. Right, I can do this. So, copying out my graph again, what we've got is, we're going from 0 to 400 up here. And this is the charge in dollar. And then on the bottom, we've got kilowatt hours. So, we're going from 0 and we're going right up to 350 for provider after 100 hours. So that's going to be something like this. And that's a nice straight line. That one is B. And provider A starts at 40. Let's put that here. And then has a shallower gradient. Now, when are they equal? Probably the question it's going to ask me, but I know it ends at, after 1,000, not 100. After 1,000, it's at 290. So it's lower, isn't it? Yeah, so this is like 290. Definitely not to scale, as all my graphs aren't, but A is going to be like here. But it starts higher, so it's going to cross like that. Something like that. Point being, shallower, I'll write it here. Shallower gradient, but obviously starts higher. That's the key point. I'm going to assume it's going to ask me when to switch, maybe. Yes. Use the two graphs to determine the number of kilowatt hours per month for which provider A and B charge the same amount. Well, it would help if I knew that. So we've got 40 plus 0.25x has to equal 0.35x. That's the equation I'm solving. So what's that telling me? That's telling me that 40 has to equal 0.1x. So 400 is x. So 400 kilowatt hours is the answer. Do I agree with that? Oh, wait. That was $140. And then 400 times 0.35 would be the same. Yes, I agree with that. Cool. So it's the one they made me work out. Nice. That was C. It's quite a long one. Part D. Custom use an average of 800. Which provider A or B would be the cheaper option? So 800 is like here. They're intersecting at like 400. Definitely not to scale. So A is cheaper. And by how much? By, let's work it out. So if we're doing 800 kilowatts, so then that's 800 kilowatts, and they charge 25 cents. So that's $200. So A equals $240 for that amount. And B would be 800 times 0.35, which I can probably read off the actual graph, can't I? I can, great. Because that's going to be $280. Do I agree with that? I do agree with that. So A cheaper by $40. Woo! Save you some money. Question 27. 27, we're getting there, slowly. Can't believe I've done 27 questions. Whizzing through them. When it's 10 a.m. in town A, time zones out. The time in town B is 2 p.m. Okay, so you've got A, 10 a.m. corresponds to B, 2 p.m. So in other words, it's plus 4 hours. Okay. Joe lives in town A and wishes to watch a so helpful live soccer game played in town B. The game commences at 11:30 in town B. So if it's 11:30 a.m., then it's 7:30 a.m. in A. When will What time will it be in town A? It lasts for 2 hours, so 9:30 a.m. when finishes. Sweet. Is that it? All right, like that one. Football and short and sweet. Question 28. Nutrition label now. So practical. I know I keep saying this, but this is, compared to UK exams, this is beautiful. I like this a lot. Nutrition label of a food item is shown. Based on the information on this label, what is the daily recommended intake of carbohydrates? Okay. So 19.1 grams is 6%. Okay. So if I multiply by 10, I can say 191 grams is 60%. So then, yes. But I want, what do I want? I want that times, not itself, 1.67. So 191 times 1.67 would give me 100%. Or I could do 191 divided by 6. I think that's really going to help though, is it? All right, I'll use a calculator. 191 times 1.67. 191 times 1.67 is going to give me what? 319. Is that correct? Maybe I should. 1.66666666. 308. I'm glad I checked. 318. 66666. Recurring, to be exact. 318.3 grams, so 318. And just to check, I was just trying to do it without using a calculator, but seeing as I now am, I can do 1.91 divided by 0.06. 19.1 divided by 0.06, which is 318.3. So the answer then is 318 grams of carbohydrate recommended. Okay, question 29. We got a graph of some locations. The diagram shows the location of 3 places, X, Y, and C. Oh, okay. Y is on a bearing. Yep. C is 40 kilometers, and that is due west of Y. Sure, P joins them. All right, so it's like a geometry problem, but in a nice real-world setting. So let's draw it. This is going to be north. We've then got, that's going to be east. So X is here. We then know that that's 15 km. Then there's a line here, right? So that's Y. This is P, which is a right angle. This is C, which is then 40 kilometers from X. Great. That's 120 degrees, which means that one there is 60 degrees. Sure. So what can we work out? Find the distance from X to P. So that's just trig. So I want to know XP. So I can say, well, XP is it's the adjacent. So A is the adjacent, which is XP. And what do I know? And I know the length of something, don't I? Yes, the hypotenuse, 15 km. So I want cos of 60 degrees equals adjacent, which is unknown, divided by 15. So XP is 15 times cosine of 60 degrees. Cosine of 60, you're coming down, and it's the later one is a half. So I think it's 7.5 km without a calculator, because I know my 30, 60, 90, etc. for sine and cos. Helpful. 7.5 km, I think. What am I doing next? What is the bearing of C from X to the nearest degree? Interesting. So what do I know? I've got a triangle. I have a triangle then with some values. We know this is 40 and this is 7.5. So I can figure out theta from here. Is this what I need? Yes, that's theta. So I've got adjacent and hypotenuse. So cos of theta is the adjacent is 7.5 over 40. So I need to do cos inverse of 7.5. Calculate, I can't do that one in my head. 7.5 out of 40 gives me a number. and then I want to do cos inverse of that answer. So I'm in degrees, and I want to do cos inverse. 79 degrees to the nearest degree. So I think theta is 79, does it say nearest degree? It does. Theta is 79 degrees, and then I want to know the bearing of C from X. So how does it describe these? It says Y is on a bearing of 120 degrees from X. Okay, so we want to go 180 plus an additional 79, so we want 259. So C is a bearing of 259 degrees in the positive clockwise direction from X, measured from the north. I'm going to just add that to be sure, because I'm not really sure exactly how you're meant to do bearings, but if we measured from north, 259 degrees. Is that it? That is it. Question 31. Nope, getting ahead of myself. Question 30. Thought it was the last one. I know that 31's the last one. Nearly there, Tom. Whew, okay, plumber leases equipment, which is valued at $60,000. Great. Let's write that down. The salvage value, anytime calculated using either of the two methods. Okay, under which method of depreciation would the salvage value be lower? Let's calculate them both. So the straight line method, so if we do the straight line, we are going to do 3,500 per year. So after 3 years, it's gone minus 10,500, 3 lots of it. So it's worth a total of 49,500. This is like salvage value. Great, declining balance. So declining balance. Again, super practical. 12%, so we need to do 12% per year. So that's 60,000. So after 1 year, you multiply by 0.88. And then I'm going to assume it's like compound. It kind of has to be, right? I think. I'm going to assume it's like compound. So it's going to be that cubed, I think. So let's try that. Calculator again. So 60,000 times 0.88 cubed. So that's 40,888. So it would be lower on the declining balance. So lower using declining balance method. But that is assuming that declining balance means compound. I don't see why it wouldn't, but I don't know because I do not know anything about depreciation. Declining balance method. Okay, is that all I need to make mathematical calculations? Sure. Final question, 31. We are gardening. Plumbing to landscape gardening. We have a drawing of a garden plan. I'm going to write that down. 1 centimeter is 2 meters. Okay. Shaded areas represent the garden beds. Fabulous. There's 3 areas. Wood chips will be laid as mulch to a depth, volume. Okay. So once volume, so I'm going to work out the area and then multiply by the depth. Okay. So let's start with the L-shaped bit. So there's, are they 10, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's 15 centimeters squared for the L. The triangle is 4 by 2 is 8 divided by 2, so it's 4 centimeters squared. And then we have a I'm going to assume it's a semicircle. So it's pi radius squared and then halved because it's the semicircle. So the radius is 2 centimeters. So it's 4 pi divided by 2 pi. So that's 2 pi centimeters squared. Great. Now, convert to meters. So 1 centimeter by 1 centimeter is 2 meters by 2 meters. So 1 centimeter squared is 4 meters squared. So I need to get the area is times 4 for the area in meters squared. It's because it's like twice the dimensions. So it's 1 times 2 in one direction and times 2 in the other, so 4 for the area. So that becomes 60 meters squared. That's going to be 16 meters squared, and that's going to now be 8 pi meters squared. So the total in meters squared is therefore the area of the flower beds is 60 plus 16 is 76 plus 8 pi meters squared. And so the volume, we have a depth of 10 centimeters, 0.1 meters. So the volume then is 76 plus 8 pi times 0.1 meters cubed. Let's just put that in. So 7.6 plus 0.8 times pi is 10.11 rounded, meters cubed. And that is the end of the Australian high school maths exam. Well, that was felt like a race against time. I think I was obviously trying to go as fast as I could. Hopefully I still gave you enough explanation to follow what I was doing. But I think this is, I don't want to say an easy exam, but it's definitely one of the easier ones I've done. Certainly one of the easiest I've done for a while. So it felt like I should be challenging myself by trying to go as fast as possible. Relatively fine, to be honest. Like, there were not really any particularly advanced concepts. It was pretty much like, can you work with figures? I really like the practicality of it though. That was really nice. But there wasn't anything that felt particularly challenging beyond some awkward numbers to put into a calculator, or in my case, try and do in my head. So I'll mark it, see what my actual score is before I make any other claims, but I think that was completely fine, and I would hope, fingers crossed, that I have got full marks. But we don't know until we mark it, so let's do that. Starting with section 1, which was the multiple choice questions, should hopefully be easy to mark. Question 1C. And I've written 4.268. Was that C? I'm going to have to look back at the paper, aren't I? Good start, Tom. C was 4.268. Okay, good. And I've done the same on question. I hope I haven't done this for all of them. Question 2 should be B. I've written $150, which is B. Right. And then I think I realised I should write the letters. What does it say? 3 is A, yes. 4 is D, yes. 5 is D, yes. Okay, moving on to the next lot. 6 was a bit of a pain to calculate, and I should have got A, yes. Good. 7 was C, brilliant. Then we've got 8 is D, 9 is C, and 10 is B. Fabulous. So I'm going to guess, is that out of 10? Yes. So 10 out of 10 are multiple choice, as I should, but still nice to get it. Now section 2. So these are the longer form questions. Right. 11, 975,000, 3,010,000, 60,200. 3 out of 3. Great. Question 12. 5.2 by 5.94. Good, that's 2 marks. And then 72 tiles, yes. And 8 boxes, great. And that was 5. 5 out of 5. Okay, question 13. The mode is 9. Oh, this weird one where it asked me to identify features of the graph. It does say an outlier at 1. And I've said the range is 9, or the total number of people asked is 24. So it only gives me one other possible thing to identify, which is that it's negatively skewed. I mean, I'd argue the things I wrote were more interesting. So I'm claiming I identified more than 2 things. So I think that's 3 out of 3. I see how they're being quite stingy with the suggested marks there, suggested answers. Okay, anyway, question 14. 100, yep, 30 minutes, yes. And then a graph, what did I draw? Slightly less steep, half of that. And if you look at their diagram, it's going through 250, yes, 250 at 4 hours, which is what I've got. Great, so that was for a total then of 4 marks. Awesome. Okay, question 15. This is the planes flying around Australia. Learned a lot about Australian geography. Complete the diagram. Right, 2650, 3270, 2120. Yeah. I'm going to assume this is all correct. That looks good for 2 out of 2, and then 4-1. Brilliant. 3 out of 3. Is that it? Yep. 16. Ships passing in the night. 369 meters. Awesome. 2 out of 2. Love that. Number 17 should be P equals 5. That was an easy one. 2 out of 2. Question 18. ABFGD. ABFGD. You got it. That's shortest route. Great. It is not. Oh. I said it was a minimum spanning tree, but it says in the mark scheme that it is not a minimum spanning tree because BC is not the shortest path to join C to the tree. So I get it now. So when I was drawing it, I'm thinking it's the shortest path. So I got the definition wrong. I had misremembered minimum spanning trees from 17 years ago whenever I did decision maths at A-level. So I thought it meant like the minimum or the shortest route between pairs, but it doesn't. Now I see the answer. Of course it's not, because it's the minimum like way to add each vertex to the tree. So I think the point is, in the one shown in the paper, B to C is 11. That's the sort of branch that's been added. But you could add C coming from G or D, would both be shorter. So if you wanted the minimum, you'd want C and D at 9. Bugger. Okay, so I'm wrong, and I definitely don't give an explanation. So I guess -2. Whoops. Oh dear, so only 2 out of 4. So -2 there. Yikes. So much for that. I told you my confidence may have been misplaced. Anyway, 19. Yes, 34 degrees. Fabulous. And B, it's extrapolation because it's outside. Perfect. It's 4 out of 4. 20. Okay. Is it an outlier? It's not an outlier. Awesome. Because it's 1.5 times the interquartile range. Although, so they've said it's 1.5 times the interquartile range above the quartiles. I mean, I argued it from above the median, so I was kind of being harsher on what made an outlier, and it was still within my harsher bound. So I slightly misremembered how to apply the 1.5 rule, but I came to the correct conclusion, so I'm going to argue I deserve 3 out of 3. Feel free to tell me in the comments if you disagree, but I think I have argued with a very sensible metric. I have argued via a stricter metric that it's not an outlier. So I think that's fine. 3 out of 3. Okay, 21. What's next? We just multiply some stuff. 14, 6, 4, 2, 28. Brilliant. 3 out of 3. Awesome. Question 22. What are we doing? Oh, the pay. 7 and 15, 49. Yes. And that's for 4 marks. 4 marks. Brilliant. 23. 5, 6, 2, 8, 70. 1, 5, 7, 5. 4, 0, 53, 70. Awesome. This was saving money on your electric car, wasn't it? So I still want to know if that's true. Someone let me know if those are true. I'm going to assume they're true figures, but let me know. That was 3 out of 3. Okay. I've learned so much about the world and the way to apply maths to it. 24, 30.54, 5121.08, and $124. Awesome. So that was 4 out of 4 for that. So still just those 2 I've lost because I don't know what a minimum spanning tree is. 25, 22, 6, 7, 3, 48. Awesome. 2 out of 2. 26. Oh yeah, electric supplier 1. Table correctly with the value 140. Yep. Draw the graph. Yep. Say that they are equal at 400. And then 280, 240 cheaper by 40. Amazing. So that's 2, 3, 4, 5 out of 5. A bit more involved, that one. Question 27. 9:30 a.m. Sweet. 2 out of 2. Great. The one about food, 318 grams. Yes. 2 out of 2. Question 29. Oh, bearings. Wasn't completely confident on this, but 7.5 kilometers. Good. And then it says now 259. Whew. Okay, 259. Not sure I've ever studied bearings, but I just followed the example they'd given in the question. So there you go. Learned something. 4 out of 4. Great. Number 30. Nearly there. What are we doing? Straight line method, 49.5, 48.88. Awesome. So it was compound. Good guess, Tom. 3 out of 3, because that's lower. Yep. And then the last one, the gardening. How much mulch do we need? 10.113. Awesome. And that was the final 5 marks. Okay. So I believe then, if I remembered correctly, it was out of 80. So I believe I've scored 78 out of 80, which is a very good score, as I very much should get. But I have dropped 2 marks because I forgot the definition of a minimum spanning tree. So there you have it, 78 out of 80. Pretty solid score. A little bit annoyed at myself for forgetting the definition of a minimum spanning tree, but you know, my brain has had lots of other things added to it in the last 17 or so years. Apparently that one's been pushed out. But overall, I think pretty straightforward exam. I really enjoyed how practical and how applied and relevant to the real world, literally like every question on the exam was. That was really nice to see, because I'm imagining that this kind of exam is going to be taken by people who are not necessarily going to go on and become mathematicians. I'm assuming the advanced and the extension papers are probably for the students who want to go on and study maths or maths-based subjects at university and beyond. So perhaps this paper was kind of taken by everybody. It feels like that, having taken it, at least. And so I really like that kind of like everyday use of all of the maths. But in terms of like how challenging was it, it wasn't, to be honest. But does it necessarily have to be, given the way the exam is presented and given, as I've now concluded, that I think pretty much everyone is taking this. So I think it was nice. I, again, really enjoyed it being practical. Wasn't that difficult, but shouldn't be for someone in my position. But you know, I still managed to drop marks, as we all do. We are all but mere humans, even as mathematicians. So I think overall, probably the easiest exam I've taken. Not the best score I've had. I've had a couple of 100%ers, but I think that might be the easiest exam I've done. It felt even easier, I think, than GCSE maths, mainly because there was additional knowledge in GCSE maths, like circle theorems, which felt more niche and felt like there was an additional mathematical understanding, whereas this whole exam was just like a manipulation of numbers and figures and very much like practical uses, being numerate in your general everyday life. Again, I don't think that's a bad thing, but on my tier list, in terms of how difficult I personally have found the exams, I think I'm going to put this as the easiest so far. Thank you everyone for watching. If there were any other exams on that list that you didn't recognize or you didn't realize that I've already taken, then do take a look at the exam playlist where you'll find all 12 or so of those videos. And please do remember to subscribe to the channel if you've enjoyed watching this. I'll see you all very soon. Take care.